Good morning. This is multiplying and dividing rational expressions, the third day of week 15. We have just spent 2 days learning how to add and subtract rational expressions, and now we're going to look at how we can multiply and divide rational expressions. Now, just like adding and subtracting numerical fractions is typically more challenging than multiplying and dividing numerical fractions. Same thing here. Multiplying and dividing rational expressions is actually a lot easier than adding and subtracting because we don't need to make a common denominator. Really, we just multiply and then simplify. So let's look at 2 examples. I think that's all we'll need for us to feel comfortable with multiplying and dividing rational expressions. Here's number 1. Number 1, we've got the fraction 4xy to the third over 15 times 3 over 8x to the fourth y. All right, so we have 2 fractions that we're multiplying together, and we know when we multiply fractions, we can just go straight across. So we're going to multiply the numerator together. Well, that would be 12xy to the third, and then we multiply the denominator together. That's going to be 8 times 15. Now we could take out our calculator for this. 8 times 10 is 80. 8 times 5 is 40, so that would be 120. X to the fourth y. And now that we've combined this to one fraction, we just want to ask if we can simplify. Now we can simplify if we can factor out a common factor. Well, in the numerator and denominator, I see that 12 and 120 both have a common factor of 12. And then I notice that they both have at least one x, and they both have at least one y. So I'm going to factor out 12xy from the numerator and denominator. That's the greatest common factor, therefore I can simplify. 12xy times y squared gives me the numerator, and 12xy times 10x to the third gives us the denominator. 12 divided by 12 cancels, x divided by x cancels, y divided by y cancels, so we're left with y squared over 10x cubed. Division, like we'll see in number 2, just adds one more step. When we divide, we copy dot flop. So let's take a look at this problem. X squared plus 3x over x squared plus 6x plus 8 divided by x squared minus 3x over x squared minus 9. So to divide, we copy dot flop. So we'll copy the first fraction, dot, and now we'll take the reciprocal of the second fraction. So x squared minus 9 up top, x squared minus 3x in the denominator. So I copy dot flopped. So next step, we're going to multiply straight across, but what we notice with this problem, we've got, in number 1 here, notice that these were all monomials, there's no addition or subtraction, whereas here we've got a bunch of binomials and trinomials. And if we want to simplify down the road, it's going to be a lot easier if we factor all of these binomials and trinomials. We'll see things will cancel out. So I would recommend here when we have like binomials like this and trinomials like this, that we factor them real quick. Now, the numerator of the first fraction, there's a common factor of x. The denominator of the first fraction, this is a quadratic trinomial whose leading coefficient is 1. So we just ask what 2 numbers multiply to get 8 and add to get 6. Well, that factors to x plus 4 times x plus 2. In the second fraction, this is a difference of squares in the numerator, we should quickly see that this factors to x plus 3 times x minus 3. And in the denominator, we can factor out an x. Now, when we multiply, we just go straight across. So really, it's like we can connect these two fraction bars. Now, if there's a common a common factor in the numerator and denominator, we can just cancel them. So let's see. I've got x minus 3 here and x minus 3 there. Those cancel. We have a factor of x here and a factor of x in the denominator, so those cancel. That's all that cancels, so the final answer is x plus 3 times x plus 3 over x plus 4 times x plus 2. And you could just leave it like that. There's no need to multiply these back out. If you do multiply them back out, you wouldn't be incorrect, but there's no need to. So if you did multiply these back out, you would get, if we multiplied x plus 3 times x plus 3, we'd make a box and get x squared plus 6x plus 9. And in the denominator, we'd get x squared plus 6x plus 8. Now, a common error is you might say, well, can't I just cancel out this x squared and this 6x and this 6x? The answer is no. Those are not common factors. Those are different terms. You can only cancel out factors, things that are being multiplied. You cannot cancel out things that are being added. So the x squareds do not cancel unless you could factor out an x squared from both the numerator and denominator, which you cannot. So either one of these is fine. I personally would just leave it here to eliminate the one extra step.